So for this problem, initially I was thinking using a Skype like a set, to find the pair. But the problem I have is like it's gonna be maintain the unique pair, right? Because if in this case I can put 3 in a set, and now I put 1, I see 1, I know 3 and 1 should be a pair, right? But then I cannot remove 3 or 1 in the set. I have to keep it in there, and I keep moving and to find another number. Then it's gonna be difficult for me to maintain a unique pair. I can use like a hash map to type, another map or another set to say, okay, if this pair is already selected, but yeah, I think I could.
So while putting, with your approach, if you make sure that you will always put the smallest element first, because you have only 2 elements, what you want to store in a set, right? For each group of 2 elements you are going to put, right? So in the beginning, you will put 1, 3, and then when you see 3, 1, you will see, hey, like 3 is bigger than 1, so let me swap it because I want to maintain the order that smallest elements will be first. So when you will try to go and put that, it will not be added to the set because it already contains that. Will that solve your problem?
So you say you keep the smaller number first in a pair?
Yeah, you have those 2 numbers, so
okay.
It's not tough. It's a temp variable, you can do that.
Yeah, hi, yes, this side. I tried this question using sets itself. We don't necessarily need to put the smaller number first. What I did was like my approach. For example, I firstly put all the elements into the stack. Oh, sorry, in the set, and then it's like if the stack, the set now has 3, 1, 4, and 5. So I started iterating over each element. And first of all, I am on the number 3. So what I did was I figured out 3 plus 2, in this case, like 3 plus k and 3 minus k, which could be the possibles, which could have all the possible pairs of, 3. So, and I counted and I put a counter, which counted if it's helping me out. After that, when I was over 3, then I removed 3, and then I iterated over the next element to check out if, I have more elements regarding that.
Yeah, seems like, Yash, you have done this question, and it seems to be nice approach for me. And it would be, what's the complexity of this particular, like it's order of n, I suppose?
Yeah, it's order of n. It's order of n for, to go through all the elements in the set, but to insert all the elements into the set, if, yeah, that's order of 1, so it's order of n.
Yeah.
But there was one
And
problem.
complexity of inserting in set is order of 1 or order of n? I'm not sure.
That's order of 1.
Okay. Yeah, that's order of 1.
But I encountered one problem into it. When the k is equal to 0, then sets wasn't helping me out.
Yeah, that seems to be a problem.
So I made a case for it, and I used maps for the specific case when k is equal to 0.
Got it.
Yeah, for k equal to 0, I just checked whether it's equal to, if the count is equal to 1, then we have to continue the loop. Otherwise, if it's greater than 1, then we can increase our count.
Yeah, it's the problem is only with the case when k is equal to 0, because we have to check all the elements which are repeating more than 1.
Yeah.
So for
there will
that,
be
I
some
use hash
special
map.
code for k equals to 0.
So yeah, seems like we have an approach. Can you share your screen if you want to share the code or something?
Yeah, just a minute. Let me just set it up. I'll share the code.
I can share mine. I have.
Okay, no problem. I'll just stop sharing.
Okay. So, is my screen visible?
Yeah, yeah.
Yeah. Okay. So, the first case is like if the k is less than 0, then we have to return 0 because we can't have absolute value as -1. So, and I used an unordered map and one set as well. It contains a pair of two integers. So in the first for loop, I just added the integer arrays, and then in the second loop, I just looked for nums minus k and nums plus k. So if we have if I got that value, then I just inserted into uh, the I inserted into the set, and I just made one special case for k equals to 0 because if the k is 0, then when we subtract or add it with the integer, then we will get the same integer back. So for that, our like count should be greater than 1. So this was the main situation. I was stuck for a minute.
So you have taken a set. Why didn't you use count for this?
Because like I need different like unique different pairs. So for that I used set because it can help me to like make the question easier.
Okay.
I can show you my approach. That's quite similar, but I guess I've used a bit less space.
Okay, wait.
My internet is troubling me a bit. Let me just fix it in a minute.
Puneet is saying he used two approaches, sorting and
I have also used two pointer approach with off one space.
I think.
I can share my screen if you guys want to. This is Yash.
Yeah, sure.
Code. Yeah. Where to? Yeah. Here you go. Is it visible?
Yes.
Yeah. So I have made two cases. Specifically, what I have done is I have figured this case out for k is equal to 0. And in case the k is 0, I solved this using an ordered map here. Okay. And if it is, if the k is not equal to 0, so for that case, let me tell you, I first used an unordered set and inserted all the elements into it. So after that, what I had done is when, it's like I was on the first element here. When IT was set to s dot begin. So this iterator is pointing to the first element. In the first example, this is 3. Okay. So here I am checking it with 3 plus k. That is if the set has an element 3 plus 2, that is 5. And if it contains that, so it will increase my count with 1. And I'm also checking it for 3 if it has 3 minus 2, that is 1. In that case also my counter will increase to with 1. Hello.
Yeah, we can.
Yeah, after that I'm just I've taken a temporary iterator, so just I can remove the 3 from the set so that it doesn't create ambiguity when I'll be on 1 or 5 later words.
Mm-hmm.
In this way I have solved it using the set. And the other case, when I had, when the k was 0, so for that case I used a map, and in the map, after inserting all the elements, I just checked if there is any element whose frequency is greater than 1. In that case I increased my counter by 1 and I returned that simply.
So you are removing which keys? Like you are removing s dot erase something.
Pardon?
You are
Okay, yeah,
erasing.
here s dot erase it2.
What is
That's basic. Yeah, that's basically like if I first I put all the elements like 3, 1, 4, and 5. My set has currently these 4 elements. Okay, so at first I was on element third. When I completed the check on element third for all the possible matches for the k, after that I erased this third from the set, so that when I'll be, supposedly like now I checked it for 3 and I got to count 2 because 3 matches with 1 and 3 matches with 5 to give k is equal to 2. After that, I erased 3 and then now I have 1. So I'll be checking 1 for 1 plus 2, that is 3, and 1 minus 2, that is minus 1.
So quick question, right? You had 3145. What if we just look in future? So 3 only looks for 5, and when 1 comes, 1 only looks for 3. It doesn't look for minus 1. 3 doesn't look for 1 because it is smaller than that. Will that work?
Pardon?
So you had.
There's some noise coming out.
Yeah, someone is like
Yeah, someone need to mute.
Yeah, there's some noise.
I think. Shall I mute the person?
Yeah.
Yeah. Go ahead and mute.
okay, looks better actually. So what I'm saying that at every number you are looking into your like neighbor, which could be like 3 minus k and 3 plus k, for example.
Yeah.
Can you just look at 3 plus k? When you reach at 1, you just look for 1 plus k. When you reach at 2, look for 4 plus k, and for 5 you just look for 5 plus k. Don't look at 3 minus k, like number which is shorter than you. Wouldn't that work?
But
What do
if
you guys
Yeah, that's a nice approach. In that case, I think I'll not need to erase the element.
But that would require the set to be sorted, right? Because you look at the smaller number, you follow in particular order. In this case, the sort is, the unordered set. So we cannot do it.
So in the first example which is given, it's not sorted. Can we just still make it work? I'm just asking the question. That's right. Like 31415, it's not sorted. But when you reach that 3, you paired it with 35, which is one pair, right? Then when you reach that 1, you could found that, hey, 1 plus 2 is 3 and it is in the map. I can make a pair. And then you are done. And then 4, it doesn't see 6, so no pair. and again we have 1. So 1 and 3 is again there, but you have already added it to your set somewhere, I believe. It depends on implementation. I'm not thinking about it. And 5 is looking for 7, and there is nothing like that. So you could figure out that there are 2 such, sets which solve this problem, I guess.
Yeah.
I'm sorry, Roger, can you explain a bit more? Like, I think I heard you, but still trying to get my head around it. You said if it is smaller than the K, then don't use it or ignore it, or what was that?
Should I help you out if you want
Yeah,
to?
please go ahead, guys, because I'm commuting, so if you will be better.
I think what Roger is saying is, like I could use just one case and then I need not erase the element again. What I was doing is I was checking for all the possible cases for the element I was iterating over. For example, like when you are on 3, what his approach says is for the first time when I am on 3, I'll be checking only for the element which comes after it, like 3 plus K. So
Okay.
if I check it for 3 plus K, so it check for 5 only. So it will increase the counter to 1. Okay. In the next pass, when the iterator would be over 1 and we have not removed 3 from our set, so then 1 will check for only one case if 3 is available to it. Okay. Then the counter would be increased to 2 because it will find 3 in the set. Afterwards, it will go to 4 and check for 6. Afterwards, it will go to 5 and check for 7. And then our iteration over the set will end, and ultimately we'll get our result. Was that the same thing, Roger?
Yes. Basically, the idea is exactly what I was saying.
Yeah, thank you. I think that explains. Basically,
Thank you, Yash. I think we have another approach. Smita was saying, Smita, do you want to explain your?
Yeah.
If anybody,
1 second.
Yes.
if anybody wants to share the screen, I could stop sharing.
Just give me 1 minute. I'm just trying to.
Actually, in the meantime, I want to say that we have two approaches for it. Like iterative one is sorting with pointer approach. I want to mention this question in one of the tests, and we need to make sure what's the K from here. Like, is it the K is range between 0 to like n, or it's starting from 1 to n? If it is starting from 1 to n, then this question can be solved using a 2-pointer approach. But if it is from 0, then you need to handle that particular case of 0. So that was one thing I just got I got when I used when I did that in the test.
Could you please elaborate about the 2-pointer approach?
So I think Smita is want to explain that problem.
Yeah, please go ahead.
Yeah.
So first, I plotted my array. And
so
then
do you want to share your screen? Smita, do you want to share your screen or?
Yes, I can share my screen.
Yeah, okay, I'll stop sharing.
Can you guys see my screen?
Yeah.
Okay. So what I did was I had to sort my array and then use 2 pointers. I started with the 0th element and the first element, which is my start and the end over here. Okay, and result is where I'm counting the elements. And what I do is I check that if ignore this condition for now. If the numbers start, I mean the 0th element and plus k, if it is greater than the array of the end element, then I will increment end. If it is less, then I'll increment the start pointer. And if it is equal, then I basically increment the result, the resultant counter. And in order to continue the loop, I am incrementing the start pointer again.
And what is this condition while start is less than length and?
This is for my loop to exit. Does that make sense?
Can you walk through with an example with this?
Yes, sure. So let's take this.
That's an interesting approach.
I had to take some corner cases separately though for this one. This is the sorted array.
Mm-hmm.
Okay. So your start is at 0 and end is at 1. So if start is equal to end, which is not the case, if nums of start plus k, which is 1, and your k is 2.
Which is 3.
3. So 3, is it greater than nums of end? Yes. In that case, we will move the end.
I think it's, it's yes.
Right?
Yeah.
Because the difference, you want the difference to be. So then you continue with the loop.
Okay.
Okay. And then 1 plus 3, 1 plus 3, 1 plus 2 is it equal to 3. This is now end and this is start now. So 1 plus 2 is equal to 3, which is the case. Then in that case, you will do, you increment your counter and you also increment your start pointer for the loop to continue. Otherwise, you'll be stuck. And this condition is for the duplicates. When you have all the duplicates, that's when this condition comes into picture.
Okay, makes sense. Yeah, I think this approach would be is interesting, but its complexity of it's like as you said, it's n log n.
Yes. I had to take all those corner cases too separately. So it was more of a spaghetti coding. That is when I took the hash map approach and I solved it through that, and that worked.
Yeah. Okay, makes sense. I think we should move on for the next question then. Anybody has doubt of anybody has other approach for this particular question? Sorry. Shall we move ahead, guys?
Yeah.